Hi, this is Yaohua at CSMD, representing the team Seafarers in the 2018 SMC Data Challenge, with Dr. Yaohua from QCMD and Dr. Byung from CSMD. We're trying to find a solution to discover and characterize three-dimensional features buried in the large diffuse scattering dataset of an interesting spin ladder compound. The dataset in question can be represented in a 3D cube with dimensionality 500 by 500 by 500 along the reciprocal axis. In total, there are 126 million data points contained in this vast volume. A simple histogram in intensity reveals a profile shown here with several first-order statistics. The biggest challenge posed by this dataset is that significant amount of meaningful signals are mingled with the pervasive noise, so that it's close to impossible to pick up the diffuse scattering pattern merely by their contrasts in intensity to the background. In order to use both photometric and geometric information provided by the 3D volume, we applied the unsupervised machine learning algorithm DBSCAN throughout our analysis and visualization. The result of the DBSCAN clustering shows there exist three domains of interesting signals. First, the majority of the cluster data points could end up in the noisy regions at either end along the Q3 axis. On the contrary, most of the diffuse scattering are collected within the central region, which has a relative high signal-to-noise ratio. Surprisingly, a third component emerges from the clustering process as shown here. Among all the clusters identified in the central regions, we pick 4 clusters which best represent the diffuse scattering patterns. Illustrated here are 2 representations with different intensity brackets. The most outstanding features we can identify in the diffuse scattering is that there exists a huge double cone structure with long extending bars at the 4 corners. On the other hand, the Bragg peaks identified here take several different shapes, such as X-shaped and T-shaped. Similarly, for the strange regions identified earlier, we show 2 intensity bracketed 3D illustrations. Most interestingly, there are 2 symmetric broomstick-shaped objects with higher than usual intensity, which are likely due to some artifacts during data reduction. However, its decisive origin needs further investigation. Briefly listed here are the spatial and photometric characteristics for each feature identified in our solution. That is, the double cone with long bar here only shows a quarter of the complete object, the X-shaped Bragg peak, and the T-shaped Bragg peak, and finally the broomstick. At the end, we thank the organizer of the SMC Conference Data Challenge for such a valuable opportunity and hope this effort could be furthered to bring more domain experts together on solving the diverse data challenges faced in their everyday life.